Okay, 6M1. Okay. Compare the, first off, we need to make a little 8-box thing on this problem here. Okay. Compare the number with an inequality symbol. So you got 20 and 10. Now, this means, again, that means greater than or less than. Okay. Remember, this here means greater than. This here means less than. Okay. Okay, 20 and 10. 20 is greater, so it should open up towards the 20. Now I want you to do something. I want you to add 3 to both those numbers. That'd be 23 and 13. Well, 23 is still bigger, so the sign did not change when I added 3. It doesn't change when you add. Now the next one, I'm going to minus 3 from both of those numbers. So 17 and 7 is what that would be. But 17 is still bigger, so when I compare the two, I still use the same symbol. Divide each number by 5, so that's 4 and 2. Okay, 4 is a bigger number. Open it towards 4. So again, it did not change. So again, what I did to get the 4 and the 2 is I took those both and divided by 5. Now divide by negative 5. Instead of positive 5, divide by negative 5. So it's going to be the same thing, only the 4 and 2 will be negative. Now negative 2 is the larger number, so the sign opens up towards the negative 2. Okay, because negative 4 is less than negative 2. So the sign changed, okay? The sign changed when you divide by a negative, okay? When you have a negative, divide by a negative on both sides, it's going to change. Now, multiply each number by 2. So multiply by 2. So 40 and 20. Well, 40 is bigger, so the sign doesn't change from here to here. Now multiply by negative 2, so that's negative 40 and negative 20. Now negative 20 is bigger, so then the sign switches. Negative 40 is less than negative 20. So the sign also changes when you multiply by a negative. Now you got to remember that, okay? When you divide by a negative or multiply by a negative, okay, we need to solve the following, and also rip off that paper, and there's something I want you to put. Opens towards X. The graph is going to go that way, okay? Because that means X is any number bigger than whatever number I come up with. If it opens towards, what should I say, doesn't open towards X, that means the solutions we get are smaller, go smaller, okay? So my directions here are solve the inequality. Now, you see you have x plus 5 is greater than or equal to negative 3. Now, normally when we solve, for equals, we just come up with one number and that's the answer. Here it's a set of numbers. It's an infinite set of numbers, meaning it goes forever and ever and ever. So we need to represent our solutions with a number line. So we put 0 in the middle, and this is example 1. Now look on the side of the x. What operations are there? Is there any multiplication, division at all? No, there's not. So since there's no multiplying or dividing going on, that sign is going to stay the same when I write my answer. So the opposite of plus 5 is minus 5. Minus 5, line your symbol up. You got x. Negative 3 minus 5 is negative 8. Now, so you have x in front of the symbol. Sometimes it'll be behind it, negative 8. So what you do is you plot negative 8, your number line. You're going to fill in the circle because the line's there. And does it open towards the x? Yes, it does. So x can be any number going that way. Negative 7, negative 6, can go on forever. Okay, example 2. 8 greater than or equal to negative 2x. Now this time, what operation does the negative 2 have with the x? So we have a times, that's a times, okay? Now, if you have a multiplication or division operation, see we didn't have one here, okay? If you have a multiplication operation, you want to circle the multiplying number. And if that's a negative, that sign needs to switch when I write my answer. Because I will be doing what I did here, which is dividing both by a negative number, okay? So if you have multiplication operation, meaning no sign in between, if that's a negative, you need to circle it, okay? Or circle it regardless, okay? Circle it regardless. And if that's a negative number, then the sign flips in my answer. So there's no adding and subtracting going on other than the multiplication, so we divide both sides by negative 2. Now this time the x comes behind the symbol, so put it behind the symbol here, and 8 divided by negative 2 is negative 4. Now you got negative 4, circle, you're going to fill in your circle. I know that's a less than sign, but it opens towards the x, okay? So that means x goes this way. Negative 4 is less than x, which means x is greater than negative 4. If you have these couple things, that'll help you out. Example 3. Again, if on the side of the x, if you have multiplication or division, you need to circle that part of the inequality, because that's when you check to see if the sign switches. You can't ignore that, okay? X divided by negative 3 greater than 8, equal to 8. So here's the x. Do you have a multiplication or division operation? Yeah, you have division, so circle the division like we did the multiplication. Do we have a negative in there? Yes, we do. So that sign needs to switch when I write my answer. So the opposite of divide is multiply, so I times by negative 3 times by negative 3. Now x is by itself. It's before the symbol, so it belongs before the symbol here. And 8 times negative 3 is negative 24. So negative 24, circle, fill it. And it does not open towards the x, so therefore it needs to go this way, okay? Okay, example 4. We have negative 4x, minus 2 greater than or equal to 14. So number line. Now let's look on the side of the x. We have a times and a minus, so we do have multiplication. Circle the multiplication division operation. Since it's a negative, the sign switches. And we get rid of that minus 2 by adding 2. 16 negative 4 times x. Now it's time to divide. Now my x is by itself, it's in front of the symbol. 16 divided by negative 4 is negative 4. So that's our solution. Negative 4, circle, fill it. It does not open towards the x, so it goes this way. So x starts at, the x solutions start at negative 4 and they go this way. Okay, example 5. 3x plus 4 minus 5x greater than or equal to 20. See, this time I have two x's in the inequality. They're both on the same side at least, though. So what I do when they're on the same side is combine them, okay, by adding. So I'm going to add 3 to negative 5. That's negative 2x. Plus 4 greater than or equal to 20. Now that I've simplified it so that I only have a single x, it has multiplication of negative 2 and plus 4. We need to circle the multiplication operation because that tells me if the sign switches. Since that's a negative, the sign should switch. Okay, minus 4. Now I don't come down here because the x isn't by itself yet. It still has a times negative 2. So when I'm adding and subtracting, I just line up the sign the same way it looks here. I got 16. Don't come here until the x is by itself. Now we divide by -2, divide by -2, and now I can come here because the x is by itself. It's in front of the symbol. 16 divided by -2 is -8. So I circle, fill it in. Does not open towards the x, so it goes this way. Okay, example 6. We have 6 times x minus 1 less than -18. So with the parentheses, I need to apply the distributive property. -6 to x and -6 to -1. So 6 times x times -1. So that's 6x, and then 6 times -1 is -6, so right, -6. Less than -18. Now, there's the only x I have. It has a times and a minus. I need to circle the times. Now, unlike that problem where it was a negative multiplication, now it's a positive multiplication, so the sign will not flip. It will stay the same, because you remember, eventually we divide by that number, and dividing by a positive, the signs didn't switch, okay? They stayed the same. So I need to plus 6. Remember, when I'm adding and subtracting, don't go down here, just right there. Because x isn't by itself, we still got the times 6. -18 plus 6, -12. Now you can divide. So x is before the symbol. -12 divided by 6 is -2. So we got -2, circle, don't fill it in. It does not open towards the x, so we're going that way. Example 7. 3x greater than 5x plus 12. Okay, first this needs to be simplified so we only have one single x. I would get rid of the x over there when solving these, when they're on opposite sides. See, there was a problem before where we had two x's, but those were on the same side, okay? So I just added them. Here they're on opposite sides, so get rid of the 5x over here. You'd minus 5x minus 5x. So I have -2x greater than 12. So now that I'm down to just a single x, what operation do I have? Just the times -2. Okay, so I circle that. Okay, it's negative, so that sign needs to switch. And I can go right into dividing. There's no number I have to add or subtract out of here, so I divide both sides by -2. So I have x in front of the symbol, because it's in front of the symbol here, it's going to be in front of the symbol even though the symbol's changed. 12 divided by -2 is -6. So we have -6, circle, and it does not open towards the x, so it goes that way. So x, any number less than -6. Okay, next up. (3x plus 15) less than or equal to 2x minus 8. Alright, so if we're going to get the x by itself, first we have to simplify this so that the x appears once. So 3x, 2x are on opposite sides, so I'll take the one over here and just get rid of it by subtracting, getting it to 0. So 3x minus 2x is 1x. Now if you get 1x, cross out the 1, you don't need it. Plus 15 less than or equal to -8. Okay, here's the x. What operations does it have? It just has plus 15. There's no times, there's no divide, so the sign would not switch because there's no multiplier or divider at all. Okay, so minus 15, minus 15. Now the x is by itself, so I can bring it down here. -8 minus 15 is -23. Circle, fill it. Opens towards the number, so it does not open towards x, so it goes that way. Okay, next one. 2x minus 5 minus 6x less than 15. Okay. Now again, you have two different x's, but unlike here where they're on the same side, here they're on here they're on opposite sides. So that's how I would get it, simplify it, so there's just a single x. Here they're on the same side, okay? So when they're on the same side, you make a v and you add 2 to negative 6. It's negative 4x. Combine like terms, minus 5. Okay, now what operations does my x have? Well, we got the minus 5, and we got times negative 4. So circle the multiplying operator. And since that's a negative, the sign switches. Okay, so opposite of minus 5 is add 5. Now we don't move down here yet because x isn't by itself. It's still got the negative 4 times x less than 20. Now I go divide. Now the x is by itself. So x, 20 divided by negative 4 is negative 5. So I circle, I don't fill it in, it opens towards x, so now it goes this way on the number line. Okay, negative 3, parentheses x plus 2, greater than 24. We have to apply the distributive property from the negative 3. So negative 3 times x, negative 3 times 2. So negative 3 times x, negative 3x, negative 3 times 2 is negative 6, which means minus 6, greater than 24. Okay, what operations does my x have? Okay, well, there's a times negative 3, so we want to circle that part, and we have a minus 6. So we plus, oh yeah, by the way, since we have a negative multiplier, the sign needs to change. So I add 6, 30, negative 3 times x. Then I divide by negative 3. We have x, negative 10. So negative 10 is a number, circle, don't fill it. It does not open towards x, so it needs to go this way. Okay, next one, 8x less than 12x plus 8. Okay, x's are on opposite sides, so get rid of the one over there by subtracting it, okay? If it would have been a minus, I would be adding it, but it's a positive 12, so I subtract it. So line that up, and you have negative 4x and 8. All right, so what operations do I have on the side of the x? Well, there's no sign between the negative 4 and the x, so that's a multiplying operation. And that's a negative multiplication operation, so the sign switches because I need to divide both sides by this negative 4 here. So we have x, negative 2. So negative 2, circle, opens towards x, so it goes to the right. Okay, 4x plus 8 greater than or equal to 6x plus 10. Okay, 4x and 6x on opposite sides, okay? So let's get rid of that one, minus 6x, minus 6x. So 4 minus 6 is negative 2x plus the 8 greater than or equal to 10. Okay, here's the x over here. It has a multiplier of negative 2, so there is a multiplication operation. Okay, again, if you have a multiplication or division operation, you need to circle it, and the sign is going to switch because that's a negative. So we subtract 8, subtract 8. 10 minus 8 is 2, negative 2 dot x. Then I divide by negative 2. We have x in front of the symbol and negative 1. Circle, fill it. Does not open towards the x, so it goes this way. Okay, 5 less than or equal to x plus 8. Okay, here's the x on this side. It does not have a multiplier in front. It doesn't have a divider, so I don't have to worry about the sign switching. To get rid of the plus 8, minus 8, minus 8. Now the x is by itself, but you need to put it on this behind the symbol because it's behind the symbol here. It goes behind the symbol here when I write my answer. And 5 minus 8 is negative 3. Now be careful, even though that is a less than sign, it opens towards the X. And when it opens towards the X, it goes that way. Okay, 5x greater than or equal to 35. Okay, here's the X. Does it have a multiplying number? Yes, it does. Okay, times 5. But you see that's positive, so the sign would not change. Okay, it's only when that's a negative multiplying number. Okay, then we divide both sides by 5, and X is by itself. In front of the symbol, 35 divided by 5 is 7. So we have 7, circle, fill it, and it opens towards the X, so it goes this way. Okay, X over negative 4 less than 9. Okay, does X have a multiplier? No, there's no number in front of it. Does it have a divider? Yes. Okay. Dividers you treat like multipliers. You circle them, and if that divisor is negative, the sign flips. Because we need to now multiply both sides by negative 4. And remember, when we multiply both sides by a negative number, the signs switch. Remember 20 and 10? When I times by just 2, they didn't change. But when I times by negative 2, then it changed. Okay, now X is by itself in front of the symbol. Negative 3. Don't change whether it's in front or behind. Circle, don't fill it, opens towards the X, goes that way. Okay, final problem. 15 greater than or equal to negative 3x plus 6. Okay, what is going on with that x? Does it have a multiplying number? Yes, it does, negative 3. So since it's negative, the sign flips. You have to get rid of the plus 6 before you worry about coming down here, though. So line up your symbol. When you're adding and subtracting, just line the symbol up. 15 minus 6 is 9, negative 3 dot x. Now divide. Now my x is by itself, but it's behind the symbol, so we keep it behind the symbol. 9 divided by negative 3 is negative 3. Now, despite the fact that that is a less than sign, it's still opening towards the x. Okay? So it goes that way.